Hi, this is Vic. In this tutorial, I'll be covering type conversion and typecasting. In Java, one data type can be converted into another data type provided they are compatible with each other. These conversions can be automatically done by the Java or they can be enforced by the programmer. So let's see them in action, and for that, let's create a class first. Here, right click at new Java class. And let's name it type conversion demo, and let's change the package com.firstlearner.programmingbasics and change the basics package to conversion and press finish. Now here is the structure of the class, and let's create a main method psvm tab. Now here is our main method. Here we'll be writing our code. Before we move on, let me tell you that Java is a strongly typed language, meaning Java requires all the variables to be declared before using them. Also, Java checks for type compatibility for any assignment done. Let's take an example for what I've said. Let's take an int I. This is the declaration part. Now I is equal to, let's assign something that's not compatible with the integer. Let's assign some string, first learner, and here as you can see Java has given an error, that is the incompatible types required int and found string. So in no way we can assign a string to a int, so this is totally wrong, and this is wrong type checking that Java does before actually compiling the source code. Let's first see the automatic type conversion that Java does implicitly by itself, and for that let's remove these and write a code for automatic type conversion. Let's take a byte b equal to 10 and int I. So we have two variables I and b. Now let's say we assign b to I. Now here you can see I have assigned a byte value to an int. When we are assigning this to the int, the byte gets promoted to int and then assigned to I. Let's S out it and see what we got here. Shift F6 and see we get the same result, that is 10. Now let's see another example. Let's take a double D and make D equal to B. So again we have done a byte to double, and the byte is promoted to double, and let's S out this one also, D, and let's see what we get. Shift F6, and here you can see dot 0 is appended to 10. This is because double is a double precision value, of floating point value, and it comes with a decimal. So here you can see the B is promoted to double. So this is how Java does implicitly the type conversion. This conversion is known as type promotion or widening conversion. Also in the automatic type conversion there is no loss of data. There is no loss of data because the destination type is always large enough to store the value of the source type. So now we'll be seeing the explicit type conversion. Let's have a double D equal to maybe 125.89, and let's assign it to an int I equal to D, and here you can see Java is giving an error and not automatically converting it. The error is possible loss of precision, required int and found double. So what we need to do is explicitly cast double value into an int value. Now how can we do this? Let me show you. Put parenthesis, and in between the parenthesis you have to write int. That is the type you want the double to cast in. Now the error has gone. Let's S out it and I, and let's see what we get. Shift F6, and here you can see D is containing 125.89, but when we printed the I, we get only the integer part, that is 125. There is loss of precision as the warning said. So whenever we are doing the explicit conversion, either we are losing the precision value or we are losing some kind of data if it is beyond the range of the destination type. Now let's take another example, the float one. Float f equals to 345.67, and here we are getting error because I haven't suffixed f here. Java needs f to identify that this is not double and this is float, because if you are using decimal and specifying nothing behind the number, Java takes default as a double. Now let's have I equal to f and cast it to int, and then s out I. Let's see what we get. Shift F6, and as you can see we are getting 345. Here we have 345.67 and we have lost the precision value, that is 0.67. So this is the explicit type conversion. We'll be seeing a lot of explicit conversion when we jump to the class inheritance part and going beyond that, the collection framework part. So the explicit type conversion, you can say it as a savior. It will be really helpful in the advanced Java part that we'll be covering in the later tutorials, and it will come in really handy. But sometimes when doing explicit typecasting, there will be result that is quite confusing. Let me show you an example for that confusion conversion. Let's remove this part. Now let me pause and do some copy pasting so that I save some time. So this is the code. Now here you can see I have taken an int with the name original value and assigned a value to 127 to it and printed it as a first value, and the second variable I have taken is a byte. The name is converted value, and typecasted the original value and assigned to it. And here what I have done is incremented the original value by 1 by using the plus plus operator and outputted the original value. And here I have again typecasted the original value after the incrementation part and assigned it to the converted value. So let's see what result we get. Shift F6, and here you can see, let me scroll it down. Now let's see, the first value is equal to 27. This is absolutely right, and the converted value is also 127 because we have assigned byte, and the maximum value that a byte can take is 127. So this is perfectly right. Now in the second value that we have here after the incrementation, we have 128, absolutely right. But here you can see we are getting minus 128 and not 128. This is because bytes range is from minus 128 to 127. Now when here we have incremented the value by 1, we got 128, which is out of the range of the byte. So what happened? Circle the range of the byte and went back to minus 128, which is the first value that it contains, minus 128 to 127. So that's why this explicit conversion can be confusing, and the result might be obscure and something that we are not expecting. So before explicitly converting a value, you should be quite careful about that. Now the last thing that we'll be seeing is the type promotion and expressions. So let's remove this part and write the code for promotion and expressions. Let's write byte b equal to 10 and int I equal to, let's say, 100, and char ch equal to 9. Oops, single quotes 9. Let's take a double d equal to 456.78. anything you like. Take another double DOU equals some expression, let's say B into I plus CH minus D, semicolon, and let's S out DOU, and let's see the result. Shift F6. Here you can see the result is a double expression. This is a byte and this is an int. So when the expression is evaluated, the byte is promoted to an int, and here in this expression char is a small type and double is the higher type, so char is promoted to double, and when this and this expressions are evaluated, this returns int and this returns double. So the final result is a double and it is assigned to a double, so this is completely okay. Now let's make some changes. Let's change the double data type to an int. Now here you can see we have an error, the precision loss, so we have to cast it to an int, the whole expression to an int. Yep, so we are done. Okay, here we have to put them in the parentheses. Now it's okay, and let's see the result. So here you can see this is the integer part only that int can contain, and there is loss of precision as per the warning. Now go open NetBeans and start practicing what you have been seeing. Make some changes and have fun with the code. So this is all for now, and see you next time.